Hello, I'm Mr. Duda with Mr. Duda, and this is project 9 of the Arduino tutorial series. It's called Motorized Pinwheel. Now, to get to this, and first of all, check out all the other projects before you go to this one. You can check in the playlist that I'm hoping is linked in this. But to get here, you go to tinkercad.com, log in. You can use a Google account or set up your own, and then you're going to click Learn. You're going to click Circuits. Let me show that again. Sorry, we click 3D and then Circuits, and then switch over to Projects and say Show All Arduino. Now, I have not made videos on those, but I have made videos on all of these, all the way up until Motorized Wheel, and that's the one we're working on today. So Motorized Wheel, it says in this project, you will spin a colorful pinwheel using a motor. The motor requires high current, so using one in an Arduino project is more complex than lighting up LEDs. You will be using a new component called a transistor to control the motor. If you're doing this in, with a real an Arduino in real life, or if you're just doing it on the computer, it'll work the same exact way. So we'll click Start. As always, I will not spend time reading through all of this for you. You're more than welcome to read through it. If you would like, you will gain more knowledge than just my video. But this is a breadboard. This is an Arduino. The Arduino can be programmed to send electricity out or receive electricity in and power different components. So let's move forward. It says in this project, you'll turn on a motor with a button. We will need one, I'm sorry, I'm not sure what the N stands for, MOSFET transistor. I'm sure there's someone that can comment on there. Please realize I am a STEM teacher, right? I am not an engineer. One diode, we have light emitting diodes. This is probably just a normal diode. Diodes only allow electricity through in one direction. 9-volt battery, see, we have to have a higher power source. Normally we use the 5 volts, but to turn the motor, we need 9 volts, a push button, and then a 10 kilo ohm resistor, and of course your Arduino, Uno, and breadboard. So this is the new thing, and I will read through this to make sure we are cool on what a transistor is. So it says creating motion takes a lot of energy. I don't know if you know this, but like your refrigerator, it has a motor for the compressor in the back, and it uses an amazing amount of electricity to start moving. Once it starts moving, it doesn't use a horrible amount of electricity, but to get it started. So if you've ever bought a generator for your house and realized you needed to, hopefully you knew, you needed to buy a much more powerful one than what you would think, because the starting energy from motors is amazing. That's why your fans, as far as I know, when you turn on your ceiling fans or your normal box fans, high is always the first setting, and the reason why is it's best to get that energy in there right away and get it spinning. Now, an engineer can jump in there and add in the comments if you'd like. I had a PlayStation engineer start talking to me in one of the Reddit sections, and I welcome your input. That would be awesome. So it says motors typically require more current than the Arduino can provide, especially if it has a heavy load attached. That means if there's something connected to the motor, if there's any physical resistance on it, any weight. Transistors are components that let you control high current and high voltage signals using the low current output of the Arduino. You can think of transistors as digital switches, or like a relay. Okay, when you provide voltage to one of the pins called the gate, which is right here, sorry, I lost my spot, it closes the circuit between the other two pins. So when electricity comes in here at a low voltage, it will make a connection between these two, okay? And just like a relay, if you have your turn signal on in your car and you're hearing that clicking, you're hearing something very similar, but that's actually a physical, something moving back and forth. Transistors, as far as I know, don't have anything physically moving in there. All right. Hopefully that worked well. Here's a little diagram of the inside, I guess, of the setup. See, the diode, this symbol means the electricity can only go one direction, and then we've got our transistor there. All right. Just ate an apple, sorry. All right. Read about how motors work, but you've got a positive and negative, and it typically doesn't matter what direction you connect it. So read through those if you want. It talks about why the diode, when you stop supplying energy to a motor, it will continue to spin. I don't know if you know this. You take a motor. If you spin a motor, it creates electricity. So if you have a motor of some kind and you can actually cause, spin it, then you'll be able to create electricity with it. So you could hook up a multimeter or something or a little light bulb and you'd be able to see that, hey, it does create electricity. And obviously we don't want that electricity flowing back into our Arduino and burning it out, right? Because it can't. It runs at 5 volts, not 9 volts, or however many volts that the motor will be creating by spinning. So it's very important to protect it from any backflow of electricity. Feel free to read through that. I'm going to move on to the setup. This one's nice and quick. There's really not much to it. Remember, you do need a 9-volt battery, otherwise this will not work. And I think my Arduino clicked a bunch of times, or the light went on and off, and it sure didn't work. So to set it up, as always, we connect, and I just want to make sure we're connecting the 5-volt and then the ground. So we take 5 volts and we run it to our positive. We make that red because red is the color for positive. Nice to keep those wires all organized. Then we connect the negative, which is always black. Ground is always black. So right here, every single hole is now positive. Every single hole here is negative because they're all connected horizontally. These are connected vertically in sections. Same with these. And then these are horizontal as well. But these don't have any power because we haven't run any power to them yet. All right. Moving forward, now what they want us to do is put the push button in. And so let's hook up that push button and then I'll talk about exactly what's going on with that, okay? So we'll put the push button in at 5. So we just take it, we drag it. If you didn't see it, you can always type it in there, okay? Push button, and then it has these terminals that we'll connect to. Remember, these are all connected, so we'll run the positive to this side. This is exactly the same as connecting this pin directly to the positive. We'll make it red because it's positive. Then we have this. So when this is pushed, the electricity will flow through here and it will go to number 2. So that number 2 should be an input. Otherwise, I'm not sure how. And then they connect a resistor. All right, this resistor right here. Now, I believe that resistor is there to split up the voltage, to lower the amount of voltage, to make this be able to read it. If I'm incorrect on that, if you're an engineer, please go ahead and add it. I said it's also to keep it safe so it doesn't, short itself out or send, you got 5 volts going directly to ground and then there's no electricity running into here. Think of electricity as water flowing through a hose. If it may take the path of least resistance and go straight to ground, and it may not send a good signal to the input on the Arduino. If I'm incorrect, please comment below. But as far as I know, that's the reason for that resistor. You'll notice the colors. It goes brown, black, orange, whatever that is. And if I look on here and I drag it in, you'll notice brown, black, red. And the reason why is it does not match. So if we look, it needs to be a 10 kilo ohm. So if you just click on it, type in 10, make sure it's at kilo ohm. If you're doing this in with real physical parts, please make sure you get the colors correctly. If you're looking for what resistance your resistor is, you can look up color charts for resistors on Google, and it's very easy. You just enter the colors and it'll tell you the resistance values. If we didn't have that there, I'm not 100% sure what would happen. Maybe the electricity wouldn't run there because the input isn't a ground, but it's going to run that there anyways. So maybe this offers a more consistent signal. I'm not sure about that. So something to look into. All right, then we need to connect our 9-volt battery. Now, however you're going to connect your 9-volt battery, number one, you'll notice we connect these grounds together. All right, so they are connecting the grounds together. I'm not sure as of right now if that's necessarily required. But hey, sounds good to me. If we type in 9-volt battery, I'm just going to type battery. Okay, there we go. So there's our 9-volt battery, and we can just connect it directly there. We want to make sure that it lines up correctly. So if I take this off and I look, this does say positive and this says negative. Why they put it right under the mouse, I'm not sure. My mouse is a little bit bigger, so maybe that's not an issue for most people. So it says plug the 9-volt battery in or the 9-volt battery adapter kit into the top rail of the breadboard. All right, so we're good on there. Right now, these negatives, the grounds wouldn't necessarily have to be connected together, but I'm not sure. All right, then they want us to place the transistor in. So we're going to look, and this transistor goes on 17. So I'm going to look up transistor. Oops. Oh, it rotated that. That looks cool. So a transistor. And if we look through them, remember there was the all the different types, and we needed the NMOS. 17. Just look that up on Google, and that'll show you more information about it. I don't want to pull that up right now, and I don't have enough information about the differences between all of these right now to be able to talk about it. I'd be more than happy to make a video on it, though, if you would like. So 17 runs to 9, and if you mouse over, you'll see this is the gate. So what that means is 9 is going to be an output, and it's going to be controlling when that gate closes, so when these are connected together. So then what we've got positive running to that side, which should be red. We have a, let me double check that. Okay, so we have a positive, and we've got that. So what's going to happen here is electricity is running here. When we push the button, the electricity will run, some of it will run this way, some of it will run to the ground. The Arduino will read, oh, someone pushed the button. And then I would imagine the programming will say, when this button is pushed, put electricity out on 9. When the electricity goes out on 9, it will close this gate. So then the electricity running from here, it'll do something. So let's move forward, and we will see exactly what it will do. So then the next one, and this is nice and easy, all we're doing is we are connecting the motor. So if you have a motor, definitely you want to get your motor, right? I apologize if I just changed something on the screen and didn't notice. We're going to grab the motor, okay? And then it has the positive, so we're looking here at terminal 1 and terminal 2. It doesn't matter the order. I'm sure someone has some reason why it should, but it doesn't really matter the order. And then what we're seeing is, right now, unless there's an additional step, I don't see why they're not running this directly to the other side of this transistor, because then when the power is running there, but we'll see. We'll see, right? We'll see what happens. So we will connect the same way they connected in 26. So we run this to 26. They had a little bit of a gap and ran it over there, and their colors were blue. Keeping those colors similar are very important, right? We want to make sure. Now we know blue is this circuit. Green is just that circuit. Purple is just that. All red is positive. All black is negative. Then our last step, they want to connect the diode. That's why it's there. That's why it's there. So the diode makes sure that electricity does not flow in an opposite direction. So we are going to look up diode. All right, and we are going to connect it. And now I probably connected to the wrong one, so this may not work. Yeah. Oh, I don't know if you can do that in real life if you're using a breadboard. I just take this and stick it in that one. The reason why is you normally can't stick 2 in the same hole, but this works. So you have, what do we have here? Is this correct? So we have positive from the battery running here, but it has nowhere to go. It has nowhere to go until this gate is opened, which then it runs to ground. And oh, that's interesting. Okay, I didn't notice this, and this is why it's important to keep the colors correct. This is a ground. This should have been black, and that's why I actually ended up running it to the ground. So I'm going to get rid of that. I'm sorry, I ran it to positive. it should be running to ground. Now it makes sense to me. Keep those colors organized, right? Now this makes sense. So when the button is pushed, electricity will flow. Number 2 will see it, and the Arduino will be programmed to say when electricity is flowing in here, then turn this on to high, right? High. Electricity will run here, 5 volts, will run here, opening this gate. Now, when basically connecting these two together. And so when you connect these two together, what you have is you have positive running into the motor over here, but it has nowhere to go because it can't flow that direction on the diode. So then what ends up happening, then what ends up happening is when this runs to here and then here. So when the gate is then closed, the electricity, the positive, it can run through here. And actually, it may run the opposite direction, but the circuit is complete, right? We can go all the way through the negative, through this gate, all the way here, through the motor, spinning the motor, all the way to positive. Electrons run from negative, or I guess if we have a positive, that means there are less electrons. So yeah, negative to positive. So either way, it's completing the circuit. And that's exactly how it works. And so now we will get into the programming of it. So I'm going to click continue. As this loads, I'm going to make sure I'm not late for my class. Awesome. I'm a 7th grade STEM science teacher, and I'm doing e-learning right now. And this is for my students, but I'm also providing it to the general public because I want people to learn all this stuff. I think it's important. So we're going to code, and just like all my previous coding, I'm not going to use their coding. I am going to use the exact coding from Arduino. So you can go to create.arduino.cc. You can go to examples, starter kit, basic kit, motorized pinwheel, and we are going to copy all of this. I press Control A to copy everything, and then I am going to go into my code. I'm going to erase what they have and paste it. You are more than welcome to read through this. I'm sure it has good information, but I like how Scott Fitzgerald writes about it. It's funny. I reached out to him to thank him for his code, and he wrote me back, and I thought that was cool. So we create an integer switch pin number 2. Right? It says named constants for the switch and motor pins. All we're saying is we are going to call number 2 switch pin, and we're going to call number 9 motor pin. And the capitalization matters. If we had a lowercase p, that would not be the same. All right. Then they're saying our current switch state equals 0. Okay. So we have this thing called switch state. We're going to say it's 0. Now, could you not have that? Yeah, you could not have that, but then it would, when it starts, I think it would just decide some random value. So it might start and the motor will be on, or it'll start and the motor will be off. We don't want that. We want it to start at 0 because we want it off, because we want it to turn on when we press the button. And then there's the void setup, which only runs once, right, when you turn it on. And it says pin mode. We're saying motor pin, which is number 9 right here, is an output. All right, and then we're saying the pin mode for number 2 is an input. And then the loop, the void loop, this is something that runs over and over and over until it's turned off. It is saying read the state of the switch value. So switch state equals the digital read of switch pin. So it's going to read the switch pin, which is number 2. So it's going to read and it's going to see, is it high or low? Because remember, this is digital. It only reads zeros or ones. So is it 0, which would be low, or is it 1, which would be high? 0 means, low means no electricity. 1 means high, means there is electricity. So it reads it, okay? Oops, sorry. It reads it. It's either going to be 0, which is low, or 0, which is low, or 1, which is high. Then it's saying if the switch state is equal to high, then make the motor pin high. So 9, send electricity through here, which will make the connection and the motor will spin. Or else, if it's low, then just keep doing the loop until it reads high. And so you should be able to say start simulation. It runs the void setup, which takes just a second. You normally see like a flashing of LEDs, I think these. And then you can push the button and you'll see that it starts spinning. And you can actually change, you could add a resistor in here if you want to rewire it. And you can see that it actually changes the speed of the motor. So that's it. Feel free to read through the rest of it. That was Project 9, Motorized Pinwheel of the Arduino tutorials in Tinkercad. And I'm Mr. Duda with STEM with Mr. Duda. Have a great day, everybody. Thank you.